Hi, my name is Abhishek, and in this video tutorial we are going to learn about projectile motion. But what exactly is a projectile motion? Let us try to understand that with the help of an example. Suppose we have an India-Pakistan match at our hands and Virat Kohli is standing at the boundary who wants to throw the ball to MS Dhoni. Now when a fielder throws the ball in air, the ball moves, as is a common observation, in the path as shown. Such a curved path is called a projectile path. So, projectile motion is essentially a curved motion which is under the influence of gravity only. Let us now move towards the physics part of the whole problem. Suppose I throw an object from point A on the ground with an initial velocity u which makes an angle theta with the horizontal. Now there might be several questions we need to answer. For example, how far from the initial point A does the object land? In other words, the horizontal distance covered by the projectile, which is normally called range of the projectile, represented by capital R. Similarly, we might also be interested in finding out the maximum height above ground achieved by the projectile, which is represented by capital H. Also, for how long did the object remain in air, which is called time of flight, represented by capital T. Now to find answers to all these questions, we need to keep in mind a very basic concept, which is any two-dimensional motion can be visualized as two separate motions onto mutually perpendicular axes. In relatively simple terms, suppose an object is moving in the coordinate plane along the path as shown. Now, by the knowledge of vectors, we can always find the component of object's velocity along x-axis, which can be called vx. Similarly, we can find the component of object's acceleration along x-axis, which can be called ax. Also, the position coordinate along the x-axis can be called x. Similarly, we can find vy, ay, and y. Now, after dividing various components of motion along these two axes, we can apply these equations of motion on x-axis and y-axis separately. Let us see how this concept works for projectile motion. Suppose a point of projection, that is point A, is the origin of a coordinate axis with x-axis along the horizontal and y-axis along the vertical. As before, we throw an object with an initial velocity u, making an angle theta with the horizontal x-axis. Now let us write down the different components of velocity and acceleration along x-axis and y-axis separately. Now initial velocity makes an angle theta with the x-axis. Hence, the component of initial velocity along the x-axis will be u cos theta, can be written as ux. Similarly, the component of velocity along the y-axis, uy, will be u sin theta. Now, there is no force acting on the particle along x-axis. Hence, acceleration along the x-axis will be 0. But along the y-axis, there is a vertical force acting, which is the force of gravity. So, Ay is equal to minus G. The minus sign represents the downward direction of the gravitational force. Having written down different components for different axes, let us now try to apply the equations of motion for y-axis. When the projectile moves from point A to point C, the component of its velocity along the y-axis gradually decreases till it becomes 0 at point C. In other words, at the topmost point C of a projectile motion, there is only a horizontal component of velocity. The vertical component is 0. Keeping this in mind, we can use the equation v equal to u plus at to find time of flight. Let us consider the motion of projectile from point A to point C. Here, Vy equal to 0. Vy is the final velocity, that is velocity at C. As we've talked about, the vertical component of velocity at C is 0. U, which is the initial velocity, is u sine theta. Also, the acceleration along the y-axis is minus g. Putting these values in equation, we get 0 equal to u sine theta minus g TAC. TAC, the time from A to C. Therefore, we get the value of t equal to u sine theta by g. Another thing to keep in mind is the fact that this is a completely symmetric motion, which means the time taken for the projectile to move from A to C is exactly equal to the time taken to move from C to B. Time of flight, which is the total time from A to B, therefore will be equal to 2 times the time taken from A to C. Therefore, we get time of flight capital T equal to twice TAC, which means time of flight is equal to 2u sine theta by g. Coming to maximum height. Maximum height is simply the maximum displacement of the projectile along the vertical, that is y-axis. In this diagram, we can see it is the distance ct. As before, we can consider the motion of the projectile from point A to point C and use the equation v square equal to u square plus 2as to find the maximum height. As before, v, which is a vertical component of velocity at point C, the topmost point, is 0. The initial component of velocity along y-axis is u sine theta. Acceleration on the y-axis throughout is minus g. Displacement can be written as capital H, which is the maximum height. Putting these values in equation, we get 0 equal to u square sine square theta minus 2gh. Substituting, we get the value of maximum height achieved by the projectile equal to u square sine square theta upon 2g. We will now try to find the range of the projectile. Range, as explained before, is the horizontal distance travelled by the projectile. In this diagram, it is simply the linear distance between point A and B. Since acceleration on the x-axis is 0, it is the case of a uniform motion along x-axis with constant speed u cos theta. Therefore, range is simply a product of velocity component along x-axis, which is constant throughout, and time of flight. Putting these values, ux, which is u cos theta, into time of flight, which is 2u sine theta by g, we get u square into 2 sine theta cos theta by g. Using trigonometric equation 2 sine theta cos theta equal to sine 2 theta and substituting it, we get the range of the projectile as u square sine 2 theta by g. For a given throwing speed u, we can conclude from the equation that range will be maximum when sine 2 theta equal to 1. In other words, when 2 theta equal to 90 degrees, or when the angle of projection is equal to 45 degrees. Hence, range is maximum when theta equal to 45 degrees. That's all for today's lecture. Remember, understanding the concept and the process is more important than memorizing the formulas. Thank you.